Newsland Octave. In the previous video, we learned how Dobrynin grouped three elements and various disadvantages in his grouping. Now let us see another classification of elements formulated later by John Newsland. In the year 1866, John Newsland, an English scientist, proposed Newsland law of octave, or simply the law of octave. When he studied the properties of elements very closely, he found an interesting pattern which I've never seen before. Astonishingly, he found that the properties of elements repeats in regular interval when they are arranged in increasing order of their atomic masses. Well, if something repeats in regular interval, then we say that there is a periodicity. For example, a month in a year repeats after every 11 months. Let us say it is the month of April now, then after 11 months, we will be in April again. Though the year is different, but we go through the same month after every 11 months. This is periodicity in months. Similarly, we can see periodicity in days of week also. Now let's come back to Newland's work. So Newland discovered the periodicity in the properties of elements for the first time. Newsland took some elements. Let's consider A to Q. Here are some elements with 1 to 17 as their atomic masses respectively. He arranged these elements in increasing order of the atomic masses like this. In such arrangement, Newsland found that properties of element A repeats again in property of element H, then again in element O. Similarly, if we consider element B, property of B repeats in element I, then in element P. Like this, if we choose any element from these arrangement, we find that its property repeats after every 7 elements. So, due to this periodicity in the properties of elements, Newsland proposed Newsland's law of octave, which states that when elements are arranged in increasing order of their atomic masses, the properties of elements repeat every 8 elements. These repetition of similar properties correspond to the octave of musical note sa re ga ma pa dha ni sa in classical Indian music, as well as do re mi fa sol la te of Western music. Hence, it is called the law of octave. Here, the word octave means step of 8. To understand better, let's discuss the actual table formulated by Newsland. Starting from this element, that is hydrogen, the elements are arranged in increasing order of the atomic masses till this element, that is calcium. In this table, if we start counting from the first element, that is hydrogen, the 8th element is fluorine. Again, starting from fluorine, the 8th element is chlorine. So according to Newsland's law of octave, these 3 elements have very similar properties, as their property are the repetition of the same property. Similarly, counting from lithium, sodium is in the 8th place. And again, counting from sodium, potassium is in the 8th place. So these 3 elements will also have similar properties. Like this, if we choose any element from the arrangement, say we choose carbon, then the 8th element from carbon is silicon. So by Newsland's law of octave, carbon and silicon will have the same property. Now if we recall Dobrynin's triad, it have the following limitations. First, he can formulate only 4 triads. Second, all elements do not follow law of triad. But was this Newlands table perfect? Or is there any limitation of it too? Yes, Newlands table was also not perfect and has got certain limitations. Newsland's law of octave holds true only for lighter elements up to calcium, which has atomic mass of 40, while there were 62 elements discovered at that time. So scientists had to find more perfect solution and they kept on searching for it. From our next video, you will be able to answer how the Mendeleev's periodic classification and Mendeleev's periodic law brought a revolutionary change in the history of classification of elements.